Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video, we are going to be looking at Pearson's correlation coefficient. So by the end of this lesson, you'll be able to understand and calculate Pearson's correlation coefficient. What is this? Well, it measures the strength of a linear association between -1 and +1. So it measures how strong the straight line relationship is between two variables. Now, generally, if you enter your data into your calculator and ask for the Pearson's correlation coefficient, if it gives you a positive correlation between 0 and +1, then generally what that means is that both quantities increase or decrease at the same time. So for example, as temperature increases, the sales of ice cream also increase. If the calculator gives you an answer of 0, it means that there's no association between the two variables. So what that means is that there is no relationship between x and y. Okay, it's completely random according to the scatter plot. It will just be completely random. There's no trend at all. If the calculator gives you a negative answer between -1 and 0, that's considered a negative correlation, and that means as one quantity increases, the other decreases. So let's say, for example, the example that I gave in the previous video, as noise levels increase, your ability to study decreases. Okay, so it's very closely linked to the gradient of a line. Okay, so that's in general. Let's have a look at the graphs. So here we said if you have a correlation coefficient of 0, so if r is equal to 0, that means it looks random. There's no relationship between x and y. However, if r is equal to +1, it forms a straight line. The graph forms a straight line. We can see that there's a perfect relationship between x and y. However, if r is equal to -1, that means the line will be sloping down. So as x increases, y decreases. Okay. The following table is a guide for how to classify the strength of a linear association. Remember, linear means straight line. Of a straight line relationship using Pearson's correlation coefficient. So if it's between positive 0.75 and 0.99, we say it's a strong positive. We describe it as a strong positive. If it's between 0.5 and 0.75, moderate positive. 0.25 to 0.49, weak positive. Negative 0.24 to positive 0.24, no linear association, etc. So what does that look like on a line graph, on a number line? We can say here that between these two, it's strong negative. Between these two, it's moderate negative. This one, weak negative. But from here to here, we say there's no linear association. Okay, so there's no relationship between the two variables. Between these two, we say there's a weak positive relationship or association, moderate positive, and strong positive. Okay, so now that we sort of know how to identify the differences between weak, moderate, and strong positive or negative linear associations or no linear association, let's have a look at how to use the calculator. So the following is a guide on how to find the correlation coefficient using the FX82 AU plus 2 and 100 AU plus For all other board-approved calculators, please use your instruction manual. So what we need to do is enter the statistics mode of the calculator by pressing mode and stat. Then we select number 2, which is a plus bx, and enter the data. After you've entered the data, press AC, select the stat menu, and choose the regression data shift 1 stat reg for regression, and then we hit the number 3 to find the correlation coefficient. So what does that look like? Let's have a look at an example. The table below shows the foot length and height in centimeters for a group of students. Find Pearson's correlation coefficient. So I'm going to get out my calculator. I need to put it in stat mode, so I'm going to press mode and then 2. I need this a plus bx, number 2, so I'm going to press 2 on my calculator. And now I've got x and y columns. Now we go back to this table of values. Remember, we always put x at the top and y at the bottom. So that means the entire top row is x and the entire bottom row is y. So I'm going to type in 24.5 and I'm going to hit equals. And I'm going to keep doing this for the entire top row. 25.6 equals 26.1 equals 25.9 equals 26.2 equals 27, 27.4, 27.5, 28.1. Now this says that I should have 9 numbers according to my calculator. Let me just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now I need to enter the y values. So I'm going to press the right arrow button here. Press down to go all the way back to the top. And I need to make sure I type the correct number that I'm meant to be typing. So next to that 24.5, according to this table here, it says I should be typing 167. So I'm going to type 167 equals. Then 168 equals. Okay, it's very important that you type in the numbers according to where they are meant to be next to. 26.1, I'm meant to be typing 170. 174. 176. 180. 181. 185. And 187. Good. Now that I'm done with that, I press this orange button, AC. In order for me to find Pearson's correlation coefficient, whenever I want to find an answer after inputting data, I need to press this 1 here because of that yellow stat. But because it's yellow, I need to press shift. So shift first, then 1. The information I provided before said I need to type in 5 for regression, REG, regression, so I'm going to type 5. And the correlation coefficient R is 3. So I'm going to type in 3, press equals, and that's my correlation coefficient, 0.95 to 2 decimal places. Now that I've done that, I can describe the linear association between foot length and height. So by classifying the strength of the association using Pearson's correlation coefficient, 0.95 is around here. Therefore, it's strong positive. Okay. I'm going to do one more question with you. I'm going to do 6a and then I want you to pause the video and have a go at question B. Calculate Pearson's correlation coefficient to 3 decimal places for each scatter plot. So I'm going to enter in the values for A, This is 1, 4. This one here is 2, 1. That is 3, 7. That is 4, 4. This one is 5, 9. 6, 7. 7, 6. 8, 8. 9, 8. And 10, 9. Okay, remember these are the X, these are the Y's. Okay. So what I'm going to do now is I'm going to enter these values into my calculator, and then it's going to give me Pearson's correlation coefficient, and I'm going to do that to 3 decimal places. So mode 2, I want the A plus BX, that's 2. Okay, I'm going to enter my data. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for X's, so that's nice and easy. Press the right arrow, press down to go all the way back to the top. Type in the Y values. 4, 1, 7, 4, 9, 7, 6, 8, 8, 9. Press the orange AC. I want my answer now, so I need to press Shift 1. Regression is 5. And Pearson's correlation coefficient R is 3. Press enter, press equals. And that's 0.731. So if I were to describe this, if I were to go back to this, 0.731 is about here somewhere, which is moderate positive. Okay. Can I get you to pause the video, have a go with question B, and when you're ready to check your answer, I'll have it ready for you. Okay, so here's the answer for question B. Pearson's correlation coefficient R is equal to 0.185, and according to the descriptions, that means there is no association between X and Y. Alright, so that's it for this video. I'll get you to work on exercise 6C, questions 1 to 4 and 6 to 10 on page 238 and 240, or 240 in your textbooks. That's it for this video.